Welcome to Processing Insight, the podcast that explores the hidden drivers of performance, operational risk, and efficiency in mineral processing plants. Today's discussion focuses on a critical issue that many operations unknowingly face every day. Hidden losses occurring while the plant is running. Because they are hidden, the magnitude of the losses is not known. Most processing plants report performance through daily and monthly performance indicators: recovery, concentrate grade, throughput, metal production, and downtime. But what if those performance indicators are hiding the real operational risks? What if the plant is losing millions of dollars while technically remaining online? In this episode, we unpack how operational risk develops within the production process itself, why aggregated performance indicators fail to explain losses, and how operating state analysis changes how we understand plant performance. Joining me today is Angela, a specialist in operational diagnostics and production process performance analysis. Welcome, Angela.
Thank you. It's good to be here. One of the biggest challenges in mineral processing is that plants often confuse reporting with understanding. At the end of every month, operations teams consolidate performance into production figures: daily recovery, grade, metal produced, penalties, and production tons. These numbers are essential for business reporting and reconciliation, but they don't explain why the plant performed the way it did. A daily recovery number is actually the result of different operating conditions occurring throughout the day: feed variability, control actions, equipment limitations, operator decisions, and instability events. When all of that is averaged into a single performance indicator, the diagnostic information disappears.
So the performance indicator confirms the outcome, but it doesn't explain the process conditions that created the outcome?
Exactly. The danger is that plants can operate inefficiently for long periods while still appearing operationally healthy. The losses are often not caused by downtime. They occur during running time, while the plant is technically operating. And that's where hidden losses exist, and most operations don't quantify them.
Okay, that's an important distinction. Traditionally, losses are often associated with shutdowns, breakdowns, or catastrophic events. But this framework suggests that losses occur during normal operation. Let's unpack that further.
Operational risk in a processing plant should be viewed as the potential loss caused by suboptimum operating states. That includes poor process conditions, equipment performance limitations, variability, and inconsistent decision-making. The important point is this: a plant can remain online while continuously operating outside its optimum state. And that inefficiency creates financial losses long before production interruptions occur. Unfavorable plant conditions cause losses, and we must be able to identify and manage them to prevent losses.
So you're saying we must reconstruct the way we measure plant performance. We must consider how to manage plant conditions to prevent losses. Why is that so important?
Because the process is dynamic. A mineral processing plant changes continuously. Ore characteristics vary, operators intervene, process interactions evolve. If you only evaluate daily averages, you lose visibility of those state transitions. The solution is to analyze high-frequency operating data minute by minute, not single variables in isolation, but groups of interrelated variables describing a specific process function.
Does this mean one would apply performance measurements for respective operating units? For example, the primary mill, classification, rougher flotation, and thickening. Can you explain what this means practically?
Certainly. Take a primary milling circuit. Traditionally, someone may trend feed rate, mill power, and density individually, but the mill's efficiency is not determined by one variable alone. The operating state is actually defined by the relationship between feed rate, mill load, power draw, and in-mill density. When these variables interact within the correct operating envelope, they produce the correct liberation or size distribution for the downstream process, and the probability of higher recovery increases. When they move outside that envelope, risk exposure and the probability of losses increase.
So, instead of asking, what was the throughput today? The better question becomes, what operating states existed while producing that throughput?
Exactly. That changes everything. Now the plant can begin answering operationally useful questions, such as, what percentage of running time was spent in the optimum state? Which operating states caused recovery losses? Which conditions resulted in grade penalties? Which process functions contributed most to loss exposure? Which shift teams sustained optimum conditions more consistently? Those are fundamentally different questions from traditional performance indicator reporting.
And importantly, those questions create a direct link between operational and financial performance. Let's talk about improvement and decision-making.
We move from performance indicator reporting to actionable diagnostics. One of the most valuable outcomes of this approach is alignment. Traditionally, metallurgist interprets performance one way, operations another way, maintenance another, and control engineers another. Everyone sees the same performance indicator, but reaches different conclusions. Operating state analysis creates a shared evidence base. Now the teams can identify which states generate losses, how often they occur, what financial impact they create, what interventions reduce exposure. This reduces reliance on subjective interpretation and retrospective opinions. This approach means the causal relationships come from actual operating data.
I assume one needs to follow a logical process to realize improvement. Can you summarize that?
Absolutely. The approach and logic are very powerful because they separate outcome measurement from causal understanding. The framework becomes a three-step process. First, monthly reporting confirms the result, and daily performance indicators show when performance changed. Second, minute-by-minute operating state analysis explains why performance changed. And finally, loss quantification determines where improvement efforts should focus, and most importantly, what improvement would address the loss. That sequence creates a much more effective improvement platform.
What strikes me is that this approach reframes inefficiency itself as measurable operational risk. Not just downtime, not just breakdowns, but find and enable the management of losses that occur during normal operation.
Exactly right. Most plants underestimate how much value is lost through suboptimum operating states. The financial impact can be enormous because the losses accumulate continuously. Reduced recovery, increased variability, grade penalties, instability, higher energy consumption, and lower throughput efficiency. The critical insight is that performance is not random. Performance is the outcome of measurable operating states. Once those states are identified and quantified, improvement becomes systematic instead of reactive.
Today's discussion highlighted an important reality in mineral processing. Traditional performance indicators tell us what happened, but they rarely explain why it happened. By analyzing operating states minute by minute, plants can quantify hidden losses, identify operational risk exposure, understand causal process conditions, improve consistency, align teams, and prioritize improvement initiatives with greater precision. Ultimately, the goal is not simply more reporting. It is deeper operational understanding. A special thanks to Angela for joining us today. And thank you to our listeners for tuning in to Processing Insight. Until next time.